recording. Okay, so for 1.4, which is on page 41 of your notes, we're almost done. We're going to look at volume this time. Does anybody want to make a guess what we're going to do for volume? Ethan?
Okay. So we got lines, we got squares, but now we have cubes. So we're
Yeah.
gonna be cubing a lot of things.
Yep.
Taking them to factors of 3.
That's exactly right. We're going to cube it. So let's work through this so that you can see why. So we're going back to our original 1 by 1 by 2 rectangular prism, and we're enlarging it by a factor of 2. So again, that's the length is twice as much, the width is twice as much, and the height is twice as much. And the volume, the volume of the original is 2. We can see that just by counting. There's 2 cubes, right? And the volume of the image, so this is the original, sorry, and this is the image. And the image has got 8 times 2, 16. It's made of 16 cubes. So it's 8 times as large. And the volume scale factor is the linear scale factor cubed, because 2 cubed equals 8. Okay, so we've got our original 1 by 1 by 2 rectangular prism. We're now enlarging by a scale factor of 4. And that is, of course, the linear scale factor is 4, right? So let's use what we learned in part up above to predict the new volume. So I'm just contemplating doing this in a slightly different order. Yeah, I'm just going to write this up a little bit different than what we've done before. We know that scale equals the image over the original. And the scale needs to be a volume scale factor. And then the image, I don't know what the image, it's the volume of the image over the volume of the original. So let's just write that formula up, okay? And the volume scale factor is the linear scale factor cubed. So that's going to give us the volume of the image over the volume of the original. And so then I'm going to have 4 cubed equals the volume of the image over, and the volume of the original was 2, which we got from up above, okay? So we get that 4 cubed is 64 equals VI over 2. So VI equals 2 times 64 equals 128. Oops, sorry. Was that confusing that I did it differently? The reason I wanted to do it this way is because I've noticed that some of you are having a hard time with calculating the scale factor and then using the scale factor, because like you calculate it using one set of numbers, but then you use it with different numbers. And I thought if we do it this way, you know, hopefully you've had teachers nagging you for years that when you do math, you flow down the page. So this becomes this, which becomes this, which becomes this, which becomes this. Okay, so it's all flowing down the page, and maybe this way works better for some of your brains. You get the same answer, so you can do it several different ways. The important thing is that you are using the linear scale factor and that your image size and your original size are in the right spots, right? They have to be in the right place in the equation, however you do it. Okay, let's just check our answer here because that's easy to do from drawing. The volume is, I have 16 on this one slice, and there are 8 slices, which is 128. So it worked. It's a pathetic happy face. Let me fix that. There. Okay. All right. And so what we've discovered is that the volume scale factor is the linear scale factor cubed. And so I know that the linear scale factor is going to be the cube root of the volume scale factor. All right, and then I've got 2 examples here of how we can use this. The Acme Globe Company produces globes with a diameter of 30 centimeters. The owner wants to put a giant globe on the roof with a diameter of 1.8 meters. So calculate the scale, the volume scale factor. So the linear scale factor is image over original length. So the image size is 1.8 meters and the original size is 30 centimeters, but I need those to be in the same units. So let's make this 180 centimeters over 30 centimeters, which is 6. So the linear scale factor is 6. 6, yeah. Okay, so the diameter of the first one is a foot, more or less, 30 centimeters, and the diameter of the big one is 6 feet, 6 times as big, okay? But we're asked to find the volume scale factor, and the volume scale factor is the linear scale factor cubed, so that equals 6 cubed, so that equals 216. So when you're talking about volumes, things get very big very quickly, okay? Or very small very quickly. All right, the owner of the globe somehow knows that the volume of the smaller globe is 0.014 meters cubed. Use scale factor. I don't know how you could possibly know that, but okay. Um, use scale factors to calculate the volume of the giant globe. So I know that the volume of it, so I'm going to use my, I know that scale is image over original, and I'm going to use the image equals original times scale formula, but I'm going to use some subscripts as well. So I'm going to say the volume of the image is the volume of the original times the volume scale factor. So that's just filling it in a little bit more, all right? And then the original volume is 0.014 meters cubed, and the volume scale factor is 216. I multiply those together and I get 3.024 meters cubed. Any questions so far? It's all the same process, right? It's the same thing we've been doing all along. It's just a matter of using the right scale factor. That's the thing. Figure out what's the scale factor you're given and what's the scale factor you need. That's the thing. Okay, example 2. An oil tank has a capacity of 32 meters cubed. A similar oil tank has dimensions that are larger by a scale factor of 3. What is the capacity of the larger tank? So my linear scale factor is 3. And I know that's the linear scale factor. Well, and it even tells me that it's the dimensions that are larger by a factor of 3. So my volume scale factor is going to be my linear scale factor cubed, which is 3 cubed, which is 27. And then the volume of my image is going to be the volume of my original times the volume scale factor. So that's 32 times 27, which is 864 meters cubed. Okay, and we're almost finished. There's only a B section of this, but I'm not going to do that today. And then we've got a couple more quizzes, and then we're ready for the test already.
When's the test gonna be?
Well, that's the next thing I was going to say. Do we want the test to be on Thursday so that this is done before your long weekend?
Yeah, probably. Sure, why not?
Okay. Okay. So it's always my policy that if we decide or I decide or whatever that the test is on Thursday and you're just not ready for the test on Thursday, don't write it on Thursday. Okay? I would rather that you took the weekend, do all the homework, figure out what you were missing and write it on Tuesday when we come back, or write it on Wednesday when then you come in on Tuesday and ask me some more questions, write the test on Wednesday. If that's going to let you show your understanding, it's going to give you a chance to learn it better and show your understanding better, I'd rather you did that. Okay. But in that case, then you're doing it outside of school time. So you'll need to come in either early in the morning or after school to write the test. Okay. So we'll have to make arrangements for that. Or maybe, you know what? You could probably even do it in we could make arrangements for you to do it on the afternoon when you're supposed to be at home working for your afternoon class. I think we could do that. Okay. Well, those are details that can be worked out. But the important thing is that, if you're really not ready for it, don't write it. Okay. But on the whole, would you rather get this out of the way before the long weekend?
Yeah.
Okay. So if we're going to do that, then you need to come in tomorrow morning ready for the 1.3 quiz. All right. And then we would do, that's tight for doing the 2 quizzes. I think we should plan on doing the 1.4 quiz tomorrow at the very end of class. Okay? So if you write the 1.3 quiz when we get here, you've got some time to do some homework in class. We'll do the next section and then we'll do the quiz and see how you're doing. And then we can do the re-quiz for 1.3 and 1.4 both on Thursday and have more work time on Thursday, and then we'll write the test, Wednesday, and the test on Thursday. Does that work?
Sounds good to me.
That's the plan? All right. Okay, so I'm finished with this. That's it for that lesson. So